We are building a fast-paced animated side-scroller game with vanilla JavaScript and HTML canvas. In the first episode, we created the main game logic, animation loop, and the player. Let's continue building our game. In this class, we will apply state design pattern to our player to make it switch between the states properly. We will learn how to control FPS, how to animate sprite sheets, and how to implement multi-layered seamless backgrounds with scrolling speed that reacts to player movement. Part 1 is linked in the video description. Let's go! I like writing my code like this for small simple games. As you can see, there are quite a lot of if-else statements in here already. I want to add some special moves. This single code block already does so many things, and we have just run in and jump in. If we keep adding more and more in here, we can get to the stage where changing one line of code can break something else unexpectedly. For small games, it's fine to have all logic in one place like this, but for this game, we will go ahead and structure our code a little bit better. I will manage player states separately in its own file. I call it player states.js. At first, I will create a simple enum object that will pair values and names of each state. It will help with code readability. Rather than swapping to state2, I will swap to state.jumpin, which has a value of 2 behind it. It will be easier to see what our code is doing. This episode might be a bit challenging for beginners. We will be passing values around between JavaScript modules and classes, and I can imagine if you are a beginner, it might take some effort to keep track of which values are coming from where. I will guide you through all the steps and we will make our code easy to navigate in, but this is the finale of my vanilla JavaScript 2D game development series, so I expect you either already watched my beginner-friendly episode on state management linked in the description, or that you have already done some JavaScript coding before. I will explain everything today. No previous knowledge is needed, but it will be easier if you watch the beginner class first. It's up to you. Today's tutorial is mainly to show you how I put everything together to make a polished animated game that feels good to play. Check the video description for the full series. I create a class I call, for example, state. Each state will have its own class so that I can give each state a different enter method to set the player up when it enters that particular state, and handle method that will react to different user inputs depending on which state the player is in at that moment in time. For example, when the player is in the running state and I press arrow down, I want to switch to sitting state. But when the player is in jumping state and I press arrow down, I don't want the player to sit in the air. I want it to do a crushing dive attack from above. State design pattern is perfect for changing how the object behaves depending on its current state. I will show you exactly what I mean as we write the code. Constructor will take a single argument called, for example, state. It will be a simple line of text with the name of the state, such as sitting, running, jumping, and so on. Inside, I convert that argument to a class property. I will use this value only so that I can console log the name of the currently active state for debugging purposes. It's not important for the logic of state swapping. We will have one class for each state. The first state will be sitting, which will also be special because it will stop the game from scrolling as the player sits down. We will export it, so export class sitting. Constructor will take a reference to the player object as an argument so that it can access properties on the player class. I am extending a class and I want the code from this constructor on the parent to run as well, so I have to call super keyword here to trigger constructor of its parent class, also known as a superclass. We can see that the parent class constructor expects a value for state. This is simply for monitoring purposes. I will pass it word sitting and it will get converted to this.state property here. Only after we called super we can use this keyword here. In a child class, if we use this keyword before using super, we will get an error. Super on child class always needs to be called before this keyword is used. Each class will have enter method that will run once when this state is entered, and handle input method that will take input as an argument, and it will keep checking if the correct key is pressed, and it will switch player to a different state when that happens. For example, it will switch to jumping state when we press up arrow key. In player.js, we will need 3 helper properties to apply state design pattern. Let's just write them and I will explain in a minute. We will need a property called this.states, which is an array of values. We will also need this.currentState, which will point to indexes in this array. When the player object is initialized for the first time, we will call its enter method to activate its initial default state. I'm exporting my sitting class here. Let's import it up here in player.js. I import the entire sitting class from player_states.js. Quick overview of how we will apply state design pattern into our codebase today. Player object will have this.states property, which will be an array containing individual states such as sitting, running, and so on. The player can only be in one state at a time, so we will have another property here called this.current_state. When this.current_state is equal to this.states index 0, player is sitting. When it's this.states index 1, the player is in the running state, and so on. The final piece of logic will be that each player state is actually its own class. We will have a class for sitting, another class for running, there will be a separate class for every state. The reason for that is that each state needs to have its own separate enter method that will set speed, animation row, and everything else that needs to be done whenever the player enters a new state. Each state class will also have a handle update method, which will listen for keyboard inputs, and it will be ready to switch the player to a different state whenever the correct key is pressed. Because all state classes have their own enter and handle input method, and because this.current_state points to different states as the player switches from one state to another, we can just keep calling this.current_state.handle_input, and we will get different behaviors depending on the current state the player is in at that point in time. And this is the entire logic behind state design pattern. If it's still not clear, don't worry, I will go over it today step by step as we write the code. It will make more sense if you practice and code with me. Inside this.states array, I will instantiate each state class. Right now, I'm creating an instance of sitting class. Here on line 14, in player_states.js, I can see that it expects a reference to the entire player object as an argument. Because here we are inside player class, I pass it this keyword, which references this entire player class. When we enter sitting state, I want to draw a different animation row in player sprite sheet. Let's set up sprite animation. We will have frame X, horizontal frame, that will cycle from left to right, animating the player, and we will have frame Y, which will travel in the sprite sheet vertically whenever we switch to a different state. You can see that frame Y0 is standing, frame Y1 is jumping, and so on. Changing the values of frame X and frame Y will jump by the width and height of a single frame so that we can animate the sprite sheet. In draw method, I replace hard-coded coordinates 0, 0, which are currently displaying this top left frame, to dynamic values. Source X value will be this.frameX times the width of the player frame. Source Y will be this.framey times the height of the player frame. I'm getting a console error. It's because I forgot a / here on line 1 in player.js. Now it's fixed. So now frame X cycles horizontally, frame Y travels around the sprite sheet vertically. I can see that the sitting animation is frame Y5. When we enter sitting state, I take this.player from line 16, which points towards the player object, and I set its frame Y property to 5. I could have defined getters and setters on the player object to do this by the book, but I don't think it's necessary for our purposes today. This code will work well. Back in player.js, I set the initial frame Y to 0, which is this standing animation. Now I need a method that will allow us to switch player between states. I define it down here on the player class. I will call it, for example, setState. It will take this new state we are about to switch to as an argument. It will be a number corresponding to indexes in this.states array from line 17. Inside, I set this.current_state from line 19 to one of the states from line 17, depending on which index I pass to it. Right now, we only have one element in the array, the sitting state, that's index 0. If we have more state classes in the array on line 17, I will be able to swap to index 1, 2, and so on to switch player to those states. Keep in mind, setState will take one argument called state, which will be a number, corresponding to the index in this.states array. Then we call enter method on the currently active state to set up things like speed, sprite animation, and so on. There's also handle input method we defined here. Enter method will run once every time we enter that state. Handle input method will be running 60 times per second, waiting for keys to be pressed so it can switch the player into a different state, when the user requests it by pressing the right set of keys. In our case, mostly arrows so far. I will be calling it from inside update method on player class here. So this.current_state.handle_input. I'm passing input value as an argument to the update method here. The value of input is coming from update method on game class, pointing to keys array on an instance of input handler class from line 15. This way, player update method can always see what keys are being pressed in our game by checking if they are present in this input keys array. We defined it before here on line 3 in input.js if you remember. We pass it through game class to update method on player class, and I will just pass that argument along to handle input method like this. This code will be running 60 times per second, constantly checking what keys are present in input keys array. Handle input expects keys array here as an argument. I called it input, and we will be checking and waiting for specific keys to be pressed. The main function of state design pattern is that we are basically locking player object in one state at a time, and while the player is in a certain state, it will only react to a limited number of keyboard inputs. While the player is in the sitting state, we will react to arrow left and arrow right keys, and when they are pressed, we will switch into running state. So I say if this input value that was passed as an argument, which points to this.keys array on input handler class, if that array includes arrow left key, or if it includes arrow right key, call setState method on player object. Here we can see that setState method expects state as an argument, and it will set the current state of the player to that index in this.states array from line 17. Right now, that array has only one element, so it will only work when I pass it index 0 as a value of this state argument here. It will then call enter method on that new state we just switched to. Back to player states.js. So now we know that we have to pass this setState method a number that will be used as an index in player states array to correctly switch it into that state. I can pass it number 0 here, but we have this enum object here to convert numbers to words like sitting and running to make our code more readable. The order of states in this enum must be exactly the same as the order of states in this.states array on line 17 inside the player class. Index 0 is sitting state because it's the first element in the array. This enum also needs to have the value of 0 paired with sitting, which it does. Now I can call setState, and instead of passing a number 1, which would also work, but it would be less readable, I pass it states from line 1 dot running, which has a value of 1 behind it as well. I hope it's a bit more clear. This is the most complicated part and we just covered it. Just keep coding with me and it will start making more sense. Right now there is no index 1 in this array yet. We need to create a running class to add it. I copy this code block and I rename it to running. And I also put running here. I check the sprite sheet and I can see the 4th row in the sprite sheet is running. So I set frame y to 3 because we count from 0. In handle input on running class, we will listen for arrow down, and when it's pressed, we switch player to the sitting state. We are exporting running class here. I import it up here in player.js, and I instantiate it as an element with an index of 1 inside this.states array. Nice, so now when we are in the sitting state and we press left or right key, we switch into the running state. When we are in running state, we listen for arrow down key, and when it's pressed, we switch back to the sitting state. Perfect, we have all the logic for swapping states in place. Let's add a jump in state. Again, I copy this code block, I rename it to jump in, and I put jump in here. I comment out line 31 inside player.js that we used for jump in before. Let's refactor it. When we enter jump in state, we set frame y to 1. If the player is on ground, that method comes from line 39 in player.js. We set velocity y on the player to -30, pushing it upwards. As we discussed in part 1, during a jump, velocity y goes from -30 to 0, moving the player upwards, and then as it moves into positive numbers, the player will start falling down. We have a nice falling animation row in our sprite sheet, so let's switch the player into falling state when it reaches the peak of its jump. Instead of listening for key presses, we can also check for values of properties on the player. When velocity y switches to the positive values and is more than player weight, more than 1, we know the player is falling down at that point, so we set state to states.falling. That will point up here, so I add fallin in our enum and I give it a value of 3. We have our new jump-in state, but there is currently no way to enter jump-in in our game. We can enter it from run-in state, for example. When the player is in the run-in state, we already listen for down arrow key. We will also be checking for up arrow like this. If input includes arrow up while the player is running, set state to jump-in, so value 2. Now I copy jump-in state and I rename it to fallin. I give it a text value of fallin in here. While we are fallin, we won't be listening for any keys. We will just wait for the player to be back on the ground and then we set state to running. We are exporting jump-in class on line 46 and fallin class on line 62. I import them up here inside player.js. Then I instantiate both of these classes inside this .states array. The order in which you do that is important and it needs to be the same as states enum we have on line 1 inside player.states.js. Those indexes have to match. You can see I'm importing jump-in as index 2 in this .states array. Fallin is index 3. And here inside enum object, jump-in has also the value of 2 and fallin has value of 3. It needs to match. While we are inside the sitting state, we can press arrow left and arrow right and it will switch player into run-in state. While we are inside run-in state, we can press arrow down to sit or arrow up to jump. To keep things simple, I can also check for arrow left and arrow right here inside update method because I want the player to be able to move left and right in basically all states when the arrows are pressed. The controls feel better that way. That means we can move left and right in the air even while we are jumping or falling or rolling. When I'm in the run-in state, if I press up arrow key, we jump, and when we reach the peak of the jump, we get automatically swapped into a falling state. When we hit the ground, we automatically switch into run-in state. Great! I adjust this minus velocity y value to change the height of the jump. Well done if you followed the code all the way here. Now you know how to apply state design pattern, which is quite an advanced technique, especially if you are a beginner. We will add more states to it soon, but before we do that, let's properly animate the sprite sheet of our dog. I want it to animate and move. I delete this line of code. We will handle sprite animation in this area, inside update method on player class. We have frame X property, which holds the index of horizontal frame. We have frame Y, which refers to the vertical position in the sprite sheet. You can see that different rows have different number of frames. I want to rotate between frame 0 and max frame on that row, depending on which row we currently are on. Sit-in state and run-in state have different number of frames. We will hold that value in this .maxFrame property, and we will adjust its value every time we swap states. Since we have our code nicely organized in state design pattern, it's easy to do that and to keep track of each state separately. Let me show you. So to animate each row, we will always cycle between frame 0 and max frame on that row. If frame X is less than max frame, increase frame X by 1. Else, reset frame X back to 0. It's going too fast and it's blinking for sit-in state because we are including empty frames. It's animating so fast because this particular sprite sheet was designed for lower frame rates. It really depends on which art assets you are using, but it's also easy to control FPS of sprite animation independently of the FPS of the entire game. I can, for example, have the dog sprite sheet animate at 10 frames per second while the entire game is still updating at 60 FPS. You can do it by checking animation timestamps and calculating delta time. It's easy, let me show you. I will explain it right now. We will need a helper variable here. Last time will hold the value of the timestamp from the previous animation loop. Request animation frame method has two special features. First, it automatically adjusts the screen refresh rate, so most of us will get 60 animation frames per second, unless you have some gaming high refresh screen. Request animation frame also auto-generates a timestamp value and it automatically passes it as an argument to the function it calls, in our case animate. I can assign it a variable name here. I will call it timestamp, for example. So this timestamp is auto-generated by request animation frame every time it serves a new animation frame, every time it loops. I will use it to calculate so-called delta time. Delta time is the difference in milliseconds between the timestamp from this animation loop that was passed here and the timestamp from the previous loop. It will give us the value of milliseconds for how long each frame stays on the screen before it gets redrawn. Last time will always hold the value of the timestamp from the previous loop, so when we used it to calculate delta time, we override last time with the value of timestamp from this loop so that it can be used to calculate delta time in the next loop. This might be a bit complicated to understand at first, but don't worry, it will make more sense as you use it more often. For this to work, timestamp gets auto-generated only when it's called by request animation frame, so for the very first initial call of animate, I have to pass it some value for timestamp. I will pass it 0. I console log delta time and I can see that it's around 16.6 milliseconds, which is around 1000 milliseconds divided by 60. My frame rate is 60 frames per second. Perfect. Yours should be similar. The value of delta time calculated this way depends on the power of your computer and on the refresh rate of your screen. So as the animation loop runs, we are recalculating delta time over and over. Every time we calculate it, we pass it the game update method. Up here on line 17, I make sure update method expects that argument. I want that delta time value to be used inside player class, so I pass it along to player update method as the second argument here. Inside player.js, we make sure that it's expected. So now the player class has access to delta time value. We know how many milliseconds it takes to serve the next frame. We can use that value to adjust sprite animation speed, for example. We can say only serve the next horizontal frame in the sprite sheet every 50 milliseconds or something like that. We can get complete control over that frame rate. It's simple. Let me show you how. This particular dock sprite sheet works the best when it's been animated at 20 frames per second. I will need a number of milliseconds for how long each frame should stay on the screen. If the frame rate is 20 frames per second, one frame should stay for 1000 milliseconds divided by this.fps divided by 20. Frame timer will cycle between 0 and frame interval, increasing by delta time for each frame. Every time it reaches the interval, it will trigger the next frame and it will reset. We will handle that logic here. If this frame timer, which starts at 0, is more than frame interval, set frame timer back to 0 so it can count again. When that happens, also serve the next frame X, horizontal frame, in the sprite sheet. Else, keep increasing frame timer by delta time until we reach that frame interval value. Perfect. Now you know how to control FPS in the game. The sprite sheet of our dock is animating at 20 frames per second. You can see it's blinking. It's because we are animating this empty frame here. For sit-in animation, max frame isn't 5, so I remove this value. When we enter sit-in state, we set max frame on player class to 4. We count from 0. When max frame is 4, we are not seeing the whole running animation, so I set max frame inside running state to 6. I will also swap max frame and frame Y to prevent occasional blinking if we swap states too fast. In jumping, max frame is 6 and falling is also 6. Now we are correctly animating each state. Do you see how it's easier to keep the code organized when we separated each state into its own class? Occasionally we can get a situation where we swap state and frame X is currently too high and that row doesn't have that many frames, so we get a quick blink. To prevent that from happening, every time we enter a new state, we set frame X back to 0 before we swap to a different vertical sprite row with frame Y. It's just a small thing. We have complete control of FPS, how fast we serve frames in player sprite sheet. I can come here and set it to 5. The great thing is that the player still moves at 60 frames per second, but the sprites are animating at 5 frames per second. We can control these two things separately. It would be very bad if controls reacted so slowly, but maybe you have a sprite sheet in your game that was designed for lower FPS. Our sprite sheets were designed for speed around 20 FPS. Depending on what art assets you are using for your game level, you might not want the player to be standing all the way at the bottom of the game area. Sometimes you need to adjust this value. Today I will give you all art assets to use, so I know we will need to create some margin on the bottom. That margin will have to be considered in more than one place around the codebase, so let's put it in the main game class so it's easy to access. I want the ground level to be 50 pixels from the bottom edge of canvas. This .ground margin is 50. Inside player.js, we have access to it through this .gameReference. So the initial vertical coordinate will be height of the game minus the height of the player minus ground margin, like this. This will not work because here I am creating player before I declare that class property. I need to put it up here, so it's available at the point when the player is created. That worked. I also need to adjust this on ground check, because being on ground now also involves this ground margin. Perfect. You can adjust ground margin value to match the environment in which your character is currently moving in. Our environment will be an abandoned monochrome city. You can download all art assets in the video description. If you are a beginner, I suggest you use my art assets first and get the game to work before you start adjusting it to your own version. It will save you a lot of headache if you encounter some unexpected challenges, because you can just look at my code to fix it. We will be animating a parallax multi-layered background. I made a special episode about this if you want to go more in depth at a beginner-friendly pace. We built a small standalone project in there showing all the concepts and alternative approaches. Let's use the quickest version here. So we have a new file I called background.js. I will need two classes here, helper layer class that will handle logic for each state separately, and main wrapper class. I will call, for example, background that will be exported and animated from the main game class. It's actually quite simple, let me show you. Layer class will need access to the game object because we need to be constantly aware of width and height of the available game area. We will also need the width and height of the actual background image. We will need speed modifier argument because each layer will move at a different speed, but relative to the current game speed. The last argument will be an image. Each layer will have a different image. All 5 images are available to download in the video description. I might also include some alternative art assets in there for experiments later. As usual, we convert the arguments that are passed to layer class constructor into class properties. Each layer will also need X and Y position, update method to move it, and draw method to draw it on canvas. You know how it goes now. I try to keep similar code structure across all classes for clarity. I could also name these methods something else if I wanted to. The background images we use today are seamless, which means that when they are scrolling from left to right continuously, we can't see where they end and where they begin. There is a small simple trick to create an illusion of endless background in a side-scroller game, and we are about to learn it right now. Click the like if you are getting any value today. We will be updating horizontal x coordinate, vertical y coordinate will always be 0. If this .x is less than minus its entire width, which means it has scrolled all the way behind the left edge of the game area and now is hidden, reset it back to 0 so it can scroll again. Else, keep decreasing x by the current game speed times speed modifier, because I want each layer to move at a slightly different speed for parallax effect. Game speed doesn't actually exist yet, so I declare it here on line 15 inside main.js. Let's set it to 3 pixels per frame, for example. Draw method will need context as an argument to specify which canvas element we want to draw on. We call built-in canvas draw image method again. This time we don't need the longest version with 9 arguments. For backgrounds we just need to pass it 5 arguments. Image we want to draw, x and y where to draw it, and width and height of that image. So this is a helper class that will handle logic for each individual layer. Our parallax background will have 5 layers. We create and combine them together in another class I call, for example, background, and I will be exporting that class. It will need access to the main game class because we need its width and height and game speed properties. I'm providing you images of a specific size for this project. The width of each layer image is 1667 pixels and height is set to 500 pixels. I made those images the exact size we will draw on canvas for performance optimization reasons. You can also use larger images and you can scale them down with code, but that will take more computing power and it can affect the FPS of your game. Let's bring all 5 images for our layers into the project. This .layer5 image is equal to layer 5. If you downloaded the project images and placed them inside your assets folder, you can go ahead and inside index.html bring them into the project. Image element with an ID of layer 5 and source assets/layer-5. video.png. I also bring layer 1, 2, 3, 4, 5 like this. In style CSS, I give all of them display none. We don't want to draw the actual image elements on the website, we want to draw them on canvas. As I said before, JavaScript automatically creates references to all elements with an ID in the global namespace, so I can just pull the images in using its auto-generated variable name like this. It would work like this, but I noticed more people are comfortable using getElementById in here, so I will do that. We will also need an array that will hold all background layers, so I created here. And here inside background class constructor, I will create an instance of layer class from line 1. I call it, for example, this.layer1, and it will be equal to new layer. You can see it expects 5 arguments, so I pass it this.game, this.width, this.height, speed modifier will be 1 for now, and the image will be this.layer5 image from line 25. Now we have one instance of our layer class. Let's put it inside background layers array. I give it update method, and inside I take that background layers array and I call forEach array method on it. For each layer object in the array, I call its associated update method. I also do the same for draw method. And I pass it context because we know it expects it up here on line 15. Let's see if it works. I import the new background class up here in main.js. I instantiate it inside game class constructor and I pass it this keyword as a reference to the entire game object because I know it expects it here. I have my background now, so I can call its update method. I get an error. We will fix that in a second. I will also call draw method on the background, and I call it before I draw the player because I want the background to be behind the player, and I pass it context. So we have an error somewhere inside our background class. The first typo I made here probably already noticed. I need to use this dot here to correctly point to the instance of layer class. Now we get draw image error, so I know something is wrong with the way I'm linking my image. If I check here, I can see I misspelled the name. It's supposed to say this.layer5 image. Nice, we are animating our background layer. I can adjust ground margin to move the player a bit up to match the background artwork. The trick to create seamlessly scrolling backgrounds is to draw the same image twice next to each other, so one at the position X and the other at the position X plus this.width, like this. I give it additional plus 20 so that we can see where the second one starts. Here. So what is happening here? We have two identical images scrolling side by side. When the main image one scrolls all the way off screen, we quickly reset it so that it can scroll again. Image 2 is never fully visible. It's just there to fill the left gap before the first image has a chance to reset. I hope this visual makes it clear what's happening. And now you know the secret of endlessly scrolling seamless backgrounds. It's easy. Let's make them parallax, which means it has multiple layers that move in slightly different speeds to create an illusion of depth, of distance. I already brought those images into our project in index.html, so I just turned them into class properties here. I instantiate each layer class with its associated image. I put all those layer objects inside this .background layers array so we can cycle through all of them at once using forEach method, inside update and draw. Now we are animating all layers at the same speed. I can give them different modifiers. Layer 1 is just gray sky, no need to move it at all, so its speed will be 0. The speed of layer 2 will be game speed times 0.2. Layer 3 is game speed times 0.4. Layer 4 will move at 80% of the current game speed, and layer 1 will move at the same speed as the actual current game speed. Perfect! You can see that if I change the modifier even higher, it gives us faster scrolling. Since we connected everything to the current game speed, I can change the scrolling speed of the game when the player switches to a different state. Maybe I want the game to stop scrolling when the player sits down, and I want double scrolling speed when the player does a special attack or a roll. There are many ways how we can structure the code at this point. I can either bring a reference to the main game object into player states so that we can manipulate game speed property from there, Or I can, for example, do it from within setState method on player class, because from there we already have access to game speed. I will give setState a second argument called speed. Inside, I set speed property on game object to the speed value passed as an argument. At first, the speed of the game is 3 pixels per frame. Since we start in the sitting state, the initial game speed should be 0. In player setState, whenever I set state, I will also set game speed. I might refactor this later, maybe it's not the best solution, but it should work. Let's see. When we are running, game speed will be 1. Sit in, game speed 0. Jump in, game speed is 1. Fall in, also 1. Run in, 1. I save all unsaved changes in all my files. Now, the game stops scrolling when we sit, and it starts scrolling again when we start moving. We can refactor this to make this code a bit better. On the game class, I create a new property called this.maxSpeed, and I set it to 3. I set this.speed to 0 at first. Inside setState, we set the current speed to max speed times the speed that was passed to setState. That way, I can adjust the actual game speed by adjusting just the max speed property on the main game class, rather than adjusting the values we passed to setState in all those places in playerStates.js. Now we have quite a lot of logic going on. If you are a beginner, well done. You should be really proud of yourself if you managed to follow along. This was the most complicated episode in this entire project. The rest will be relatively easy when you understand the tips and tricks I'm about to reveal. It's important that player feels like they have control over the character. Quick responsive controls add a lot towards positive user experience. Click the like if you found any value today. In the next part, we will add multiple types of dangerous enemies. The full series playlist is linked in the video description. I'll see you there.